Okay, so in this video, I'm going to talk about two very similar view groups, the ListView and the RecyclerView view groups. To start things off, we're going to take a look at what we're looking at here, which is the ListView, which is arguably the simpler of these two view groups. You build the two view groups very similarly, and the recycler view being a little bit more complicated. But you'll see how the two relate as we go on. So here's a list view. You can see that there's a sequence of similar items being displayed in the list. When I click items in the list, there's an event handler that registers the click, and it registers the click on the item that I clicked. So I can get a reference to the item in this list that was clicked. So each one of these items is a object inside of a collection. In this case, it's an array of Lego kit items, Lego kit objects, the Lego kit class being something that I defined in my code. You don't need to know much about the Lego kit class, except that it's a very simple class that exposes three getters, which provide the title and the ID and the number of pieces in a Lego kit. But you'll notice that this list view has a sequence of views for each item. So for each item in this list, there are three views, all of them being text views that show the title, the ID, and the pieces in that item. And that's really the point of a list view. A list view allows you to take a collection of data and represent it as a list using a predefined set of views or in a predefined layout. It allows you to bind data, is a phrase you might use. It allows you to bind that data to a group of views so that you get this nice, regular, repeated pattern for your list. You can use, if you're so inclined, just a regular array of strings or even an array of integers. We saw something similar to this in class when we discussed the spinner, but in this case, we're going to look at how to create a custom adapter for a list view, which is why I'm using my own custom class. So let's take a little bit closer look at this. So we'll start by taking a look at my definition of the list view. And again, you'll notice that there's not a whole lot here. I've just given my list view the ID and defined its layout, width, and height, which is required, and given it some margin so it doesn't come right up to the sides of the emulator. But really a very, very simple definition. I could have defined a data source right here in the XML, but in this case, I decide not to. Instead, I'm going to bind the data source to the list view inside of the onCreate method of the host activity. And here's that activity. So obviously, I set up the content and I inflate my layout by getting a reference to this file, to this layout file. And then once I've inflated my layout, then I'm going to actually start connecting up the data into my list view. So first I'm going to get my data source, which in this case is just an array of Lego kit objects. And then I'm going to create my custom adapter. Now, Android has some built-in adapters, like specifically it has some adapters for like strings and integers, but all they do is just display like a array of strings. If you want to do something any more complicated than an array of strings, like a custom class, then you're going to need to create your own adapter. And the way to think about adapters is that they take a data source and they bind them to individual views, to a small collection of individual views that represent a single item inside of the list view, inside of this view group that holds a repeated pattern. Now, in my case, I've created a custom adapter called the Lego Kit Adapter. We're going to look at that in just a couple of moments. And then to set the adapter, it's pretty straightforward. So you'll notice I'm going to get a reference to my list view. And then I'm going to set the adapter for the list view using a setter. And then I'm going to create set an item click listener to my list view so that I can then respond when an item in the list view is clicked. Now, in this case, list view has its own nested interface on item click listener, which has a single required method that you have to implement, which is on item click. And in this case, I've created an anonymous implementation of the interface that calls on item click. So again, this is the pattern that we talked about in class, specifically with the spinner and with the date picker dialog. But this is, again, a very, very common pattern that you see in Android development. So where things get a lot more interesting is in the adapter. So we're going to take this slowly. First, you'll notice that the adapter is a subclass. That means it inherits from the array adapter class. And the array adapter class, when I inherit from it, I actually specify the data type that I want to represent inside of my adapter. Now, inside of the implementation for my adapter, you note that I'm going to create two fields. One which is going to store the context of the adapter, and usually this is going to be the application where the list view is created. And then I'm going to store a reference to the data that I want to represent. In this case, the array of Lego kits. Now, when I create my adapter, you'll notice that I'm going to have my constructor, nothing weird here. In the constructor for the superclass, I'm going to pass in a reference to the context. I could actually also specify a resource, a layout in the inside of my project. In this case, I decided not to. And I could also, I pass in the values that I'm going to represent. In this case, the Lego kits, right? So that represents a array of Lego kits. And then I just set my two private fields. So pretty straightforward Java programming here. Now, where things get a little bit more interesting is right here in this method, the getView method. And getView, this method allows you to generate the individual views that go inside of a single item in the list view. So if we go back to the list view, like I said, you'll notice that each one of these items is a linear layout, which contains a label with the title, a label with the ID, and a label with the number of pieces. So when we come back to this, you'll see I create a linear layout. I'm going to then set the orientation. And then I create each of my text views. I then add each of the text views programmatically to my layout. And then I return the layout to the calling code. Now, you don't actually have to call getView yourself in your code. The ListView view group is smart enough to know that it needs to call getView for each item in your data set. But in order to help ListView do its job, you actually have to define this getView method. If you don't define the getView method, if you don't override it, you're simply not going to get your content rendered in the way that you want. But really, this getView method is where the magic happens. It's where you connect the data source that you're trying to represent with the views that are going to represent it in your list. So ListView is pretty straightforward, and for a long time it was the fundamental way of representing lists inside of an Android app. Well, one of the things with ListView is that you actually have to do some extra work in order to make sure that in really, really large data sets, so imagine you were creating a ListView that had all the contents of the Library of Congress, right? That would be a huge data set. And if your app tried to render it, it would crash and it would be bad news. So if you're using a ListView for that data set, you would need to do something really, really sophisticated, like only providing X small subset of data inside of your really, really large data set. And then you'd have to keep track of where you're at in that data set. And such that you weren't creating too many views, and then you would have to manage the views inside that list view. It would become a royal nightmare really, really fast. Well, the RecyclerView was designed to overcome some of these problems. So one of the benefits of the RecyclerView is that when an item is in the data set but not visible, the views aren't necessarily going to be created. That saves you some memory, right? So if your app is running on one of those really small devices that we talked about in class, you're not going to be killing the memory. And of course, like the ListView, before, you notice that we can add an item clicked handler and get a reference to the item in the list that raised the view. So we get all of the power of a list view with some extra benefits as well. So built-in scrolling and much better memory performance. Now, one other thing that you probably noticed is that in this case, the RecyclerView has this nice, pretty card layout that I've rendered things in. And this is just like a single line of stuff. That isn't inherent to RecyclerView, that pretty card layout. I'm actually using a card view as the host layout inside of the RecyclerView, mainly because card views are pretty and I like them. But you could get a layout that looks similar to this using a list view. So this design is not inherent to the RecyclerView. It's just because I was doing something different in this RecyclerView with rendering the views inside of it for the items rather than ListView. So with that, let's go ahead and switch to the code. And so here's the XML. You'll notice again a really, really simple XML definition. All I really do is I create RecyclerView, I give it an ID, and I set the layout, width, and height to match parent. Now, one thing I want you to notice is kind of interesting. The RecyclerView is the root element of my layout. This is totally and completely legitimate. Just like as we've seen with class, where if you're creating a user interface programmatically in Java, you can use setContentView to set your entire user interface for an activity to just a single text view. Likewise, anything that inherits from view can be set as the root element in an activity layout. So any of these things that we've been looking at, heck, I suppose you could even use a checkbox as the root element for your activity. That'd be a really, really boring activity, but heck, you would know that box is checked, right? So that's worth pointing into. The only thing that is different is about using this as the root of the layout is that you then have to also import your namespace into this widget in order to be able to use the attributes defined in the namespace, right? So let's go ahead and take a look at the code. Java. All right. So again, I'm using the same data set, still using my Lego kits because I like Lego. Nothing wrong with that. And you'll also notice that I've set up the RecyclerView really, really simply. The setup code here in this activity is very similar, almost exactly the same to the setup as the ListView. So I just create my content. I set my content view to my layout. Then get a reference to the RecyclerView. I then get a reference. I get my data source. I create my adapter, and then I set my adapter and assign my listener, my click listener. There is one major difference though, and that is these two lines right here. RecyclerView is really cool in that you can specify a specific layout for it to render your data. And you have a couple different options. One of the options is this guy right here. It is the linear layout. And these are these various layouts that you specify are contained within layout managers. There is also a grid layout manager, which will, rather than getting this nice individual items like this, you'd have one here, one here, one here, one here. And then there's a staggered grid layout manager, which allows to give you an even grid looking thing, which is pretty cool and probably something you would see on, say, like a newsstand style app, right? But in this case, we're using something really similar, a good friend, the linear layout. And it just gives us a straight up and down, or if I had wanted to, a side to side view of our items. So that's one of the major differences between RecyclerView is that you have to use the layout manager. So where things start getting really, really crazy is in the code for the adapter. And we'll take this one step at a time. Now, first thing to recognize is that our adapter, our custom adapter, needs to inherit from this RecyclerView.adapter class, and it takes as an object that it holds as a collection, a view holder. And it's kind of weird because in the ListView adapter, our adapter simply took views and then slapped them together with data. With RecyclerView, you actually have a separation of concerns here where you have the adapter that slaps the data into the view, and then you have a view holder that actually defines the view. The view that contains the subviews. It gets a little bit more confusing. The result is the same. It's really just a difference in implementation style. It does actually have an effect when it comes to the listener, which we'll see in a few moments. So one of the things that you have to do when you create a RecyclerView adapter is you create a
definition of your view holder class, which of course implements RecyclerView view holder. And it's usually a really, really simple definition, right? In this case, I have created my view holder that the constructor takes a single element, which is, or a single argument rather, which is a card view, and then I set that as the field inside of the view holder. That's it. Just a class definition with a constructor. That's all there is. Now I have a reference here inside of my adapter class. So we're moving outside this nested class, going back to this recycler adapter class. I have a reference to my data source, again, very similar to ListView adapter. And then I have these listener members hanging out up here. I'm going to come back to these. So set these aside. Don't worry. If you're looking at all this code and be like, oh my gosh, he's skipping parts. Don't worry. I'm going to come back to it. I'm going to explain it in just a minute. But we're going to set this aside for the time being. Then we're going to scroll down here. So first thing that we see is this, the constructor for our recycler adapter, and takes a single element and just takes a reference, or it takes a single argument rather, just takes a reference to the data source that we're going to render, which is an array of Lego kits. Pretty straightforward. Then we have another required item for us to override, which is this get item count method. Again, a really simple implementation. It just returns the length of the data set. So here we have two methods that are different but related. The first one is on create view holder. And essentially all it does is create a new instance of the layout that is going to be the root of your view holder. So in this case, you'll notice that what I've done is I've created a card view object. And what I'm going to do is I'm going to inflate a layout that I've already defined elsewhere in my code. So this right here is getting context. It gets a reference to activity. It's what allows you to get a reference to the resources in your package. But basically, this just allows you to connect to all of the stuff that's a part of your Android app. This method called right here. But right here, what you can see what's happening is that we're getting a reference to a layout that I've created. And I'm going to apply it to the parent. It's parent object, which is a view group, and attached to root, which I'm not going to talk about today. And then I create a new instance of the view holder. So you might be wondering, okay, well, what is this layout look like? And here's that layout. This is a bit more involved than the layout for our recycler view by quite a lot. But without spending too much time talking about this is a card view layout. It's a view group, and it allows us to create this nice, cool design where you've got a nice little drop shadow and slightly rounded corners. It's part of the material design aesthetic. And you'll notice that it also therefore, and inside of it, it defines each of the text views that are a part of the items inside of my recycler view. So again, this is a case where you can define your user interface programmatically using Java, or you can define it in XML, depending on your preference. If you have a really simple layout that you're creating, or a really simple item layout that you're creating, you probably don't need to define something big like this. You can probably do it entirely in Java code. But if you do want to do something that has some real panache and style, basically anything that does any sort of material design stuff to it, you're gonna want to have a bespoke a custom layout file for your list items. So put that guy away for now. So the onCreateViewHolder method simply creates an instance of your view holder, and it instantiates your root element for your view holder by getting a reference to your layout. Now, when it does this, the card view that the root layout that gets created already contains all of the views inside of it, all of the child views inside of it that we're going to need to in order to render our content. And so then we come to the onBindViewHolder method, which is where we actually start binding data to views. So again, a very, very similar process to the list view, where we're going to get a reference to the views that we want to apply data to. And then we're going to set the data. And this one is different, slightly different, where one than onCreateView for the ListView adapter, and that we get a reference to the card view, which is the root element, when this gets called. So it saves you a little bit of time. But the other thing is this part right here, where we're going to set our onClick listener. Now this is where things get a little bit weird. Okay, so we're going to set an onClick listener to the card view, and we're actually going to you're going to notice this is the view onClick listener. This is the default view.onClick listener that's part of the view class, right? The thing that we've been assigning click events to from the first time we started looking at views in XML. Right? And what we've done here is we've done something interesting where we've defined our implementation of onClick, but then we've done something weird. We said if listener is not equal to null, then what we're going to do is we're going to call the onClick method of the listener. Well, what is this listener? That's where we have to go all the way back to the top. All right? Here's where that gets defined. So first we have a private member listener, and this private member listener is of a type of listener that we have then defined right here. Since we haven't imported anything called listener, and this gets defined here, this is a reference to this type right here. So if you're freaking out thinking like, oh, where did he import this listener thing? I don't have to import it because I defined it right here. Now, one of the things that you'll notice is that my adapter exposes a public method called setListener. It takes as an argument a single object, which is a listener, one of these listener types, and then it sets the private listener field to the listener that gets passed in. So this is kind of like a functional programming paradigm where it's where functional programming meets Java object-oriented programming. So we're all familiar with this idea of getters and setters, right? Where you have private fields, and with your private fields, you don't want to allow callers of your class to get direct access to your fields. So instead, you restrict access to those fields by creating getters and setters. Well, here in this case, we're doing something very, very similar, except we're defining a setter for our click listener. So you'll notice we've defined a setter for our click listener. We've also defined the type for our set listener. So basically, anybody who wants to set a listener for our adapter has to create an instance of our type of listener in order to be able to set it. And then when they do set the listener, we get a reference to the listener that they define, and we're going to set it as our private field here. So there's a couple layers of nuance here that allow us to create this predefined listener, item click listener. And this is another one of the Android development patterns that you're going to see crop up over and over again, where you're going to have you're going to create a nested interface that you also then define a setter for, so that external consumers or callers of that class can then define or can create an instance of your class and also set an event listener for that class that you've already predefined in a way. So this is a really quite nifty programming style for those of you who are programming pattern geeks. So as you can go back, we take a look at the RecyclerView activity, and you'll see that's what we've done here. So we've actually created a new instance, an anonymous instance of our Lego kit recycler adapter.listener interface, or an object that implements it. And then we create our click listener. And then when we call this setter on our adapter, now this gets called. This listener is therefore goes from being null to having a listener applied to it. And then when we click an item in here, right, this click listener fires, and it's going to check, okay, is that listener that's defined all the way up here, does it exist? If it does, call the base view on click listener for our card view. Take some time and look at the code that I've uploaded for this and trying to follow the logic, because there's some spaghetti strands going on here that once you grasp it, you'll see that this is actually a really clever design. The reason for doing this is that you want to make sure that your adapter is reusable in multiple different types. You also want to be able to control which views inside of your card view are going to raise the on-click listener. So that pretty much wraps up our video on recycler views and list views. I think the last thing that I would like to talk to you about here that's critical for using these guys is how to add RecyclerView in particular into your project. So RecyclerView is actually part of a support library. I don't want to go too far into it, but in addition to the core Android framework library, there are also additional libraries called the Android support libraries that frequently include things like interesting additional user interface elements. Not the least of which being like material design elements. So in order to add a reference to RecyclerView, or CardView for that matter, because CardView is also part of that support library, there's a couple of ways here. One is that you can add the reference directly to your app's build.gradle file right there. Now, to add these to your build.gradle file, you need to know exactly what you're adding. So that's kind of fraught with difficulty sometimes. But there is an easier way. You can right-click the app, then hit Open Module Settings. Ooh, that's big. Let's resize that guy. There we go. And then we come over here. We see that we've got our app module selected. We come over to Dependencies, and voila, there it is. To add a new dependency, we're going to hit the plus button. We're going to pick library, and then we're going to pick what we want to add. And you can see there's a whole bunch of stuff we can add here, right? Okay, so that's hopefully everything that you should need to know in order to create a recycler view or a list view. Of course, if you have any questions, send them to me over email, and have fun creating recycler views. They're pretty neat, I have to admit.